Hi everyone, a very good evening and welcome to today's live session. This is Gayatri here, and today we are going to be doing a concept session, and the topic that we are going to be discussing is time and distance from quantitative ability. And this is a very important topic when it comes to quantitative ability, because definitely you can expect at least one question or one or two questions from this topic in your examination, right? Usually questions on time and distance is common when it comes to bank and SSC examinations. So first, as we do always, since this is a concept session, we will first discuss the basics of time, speed and distance. We will discuss what are the things that you need to know from this topic, and then we will go about solving questions from this topic. Now, when it comes to time, speed and distance, the most important concept, what is the most important concept that you should know? The most important concept that you should know is that distance traveled is always equal to the speed into the time taken, right? Distance is equal to speed into time, or I can say time is equal to distance divided by speed, or speed is equal to distance divided by time. So this is the most basic formula that you need to know from time and distance, or all the other concepts that come from this topic is basically derived from this one formula. Okay, so now let me share my screen, and we are discussing time, speed and distance, right? Now, the first and foremost, or the most important formula that you need to know is equal to distance is equal to speed into time, or I can say time is equal to distance by speed, or speed is equal to distance by time. So these are the three important variables also involved in questions from this topic. Next important thing that you need to know is the units of each of these variables. Distance is generally measured in terms of meters or kilometers. Speed is generally measured in two types, right? Okay, either it is generally in terms of meter per second or kilometers per hour. Time, usually the units of time is either seconds, minutes or hours. Okay, so these are the general units that you use, right? For distance you use meter or kilometer. Sometimes even questions come on miles. I'm not saying that all those won't come, only meter and kilometer will come. But in general, these are the units that you use for each of these variables. Now, one very important thing that you need to look at when you get a question from time and distance is that you have to check that all the variables in the question have the uniform or the similar units. Let's say if distance is given in terms of meters and time is given in terms of seconds, speed has to be in terms of meters per second. Similarly, if speed is in terms of kilometers per hour, right, distance has to be in terms of kilometers and time has to be in terms of hour. So only always check this, right, that the units are uniform throughout. I mean, all the units are similar for a given question for all the variables. This one thing you will have to note. So to know that, to make these units the same, right, or similar, what you have to do, the next thing that you need to know is conversion, right? See, what is one kilometer? 1 kilometer is equal to 1000 meter. Let's say in a question the speed is given in terms of kilometers per hour and the distance is given in terms of meter. Then what does that mean? You will have to convert the distance into kilometers. So you should know these conversions also. 1 kilometer is 1000 meters. Similarly, when it comes to time, you know that 60 seconds is equal to 1 minute. Similarly, 60 minutes is equal to 1 hour. So what is 1 hour in terms of seconds? It is nothing but 60 into 60 seconds. Next, coming to speed. Now similarly, when you are converting, see if in the question the speed is given in terms of kilometer per hour and you want to convert it into meter per second, or in a question the speed is given in terms of meter per second and you want to convert it into kilometer per hour to standardize the units. What formula do you use? So this is the conversion for speed. See, if you have 1 kilometer per hour, this is equal to 5 by 18 meters per second. Similarly, if you have 1 meters per second, this is equal to 18 by 5 kilometers per hour. So these are the conversions that you should know when it comes to the topic time and distance. Very important, whenever you get a question, first look at the units of the variables and see if they are standard throughout the question. Else, make that uniform first and then go about solving the question. Okay, so we are just discussing the basics of time, speed and distance. This is the first and foremost concept that you need to know. Next thing that you need to know is what is called as average speed and distance. You need to know only very few basics, right? Like first, the relationship between time, speed and distance and their units, what we just discussed right now. The next thing that you need to know is what is average speed, concept of average speed. Then you need to know the concept of relative speed. All these other topics like trains, boats and streams, races, all these are application of these concepts that we learned, and you should have a very good understanding of the concept to be able to solve questions from this topic. See, I always say just by learning shortcut formulas you are not going to do well in the examination. You should have a clear understanding of the topic also, the concept also, because suddenly you go to the examination, you forget a formula, you forget whether it is a plus or a minus in the formula. If you know the concept, you will know why that plus came there, why that minus came there. So then you will never go wrong. Yes, that is the importance of concept when it comes to quantitative ability. So next concept that we are going to learn is the concept of average speed. Now, when it comes to average speed, again, as I said, formulas, you can see a lot of formulas in a lot of books, right? Different, like there will be 3 or 4 formulas from the concept of average speed. I would say just remember one formula for the concept of average speed. What is average speed? Average speed is nothing but equal to the total distance divided by total time, right? This is the formula for average speed. But what I am saying is, just if you know this formula itself, you can solve any question from this topic of concept of average speed. Let us try to explain what average speed is. What are we trying to say here? Okay. Now, assume that there is a person. He is traveling a distance of, let us say, 20 kilometers. Okay. He is traveling 20 kilometers at a speed of, let us say, 40 kilometers per hour. Okay, and then next another 10 kilometers. Okay, he is traveling at a speed of, let us say, how much, 30 kilometers per hour. Okay, now my question is, what is his average speed? What is the question here? There is a person who is traveling 20 kilometers at a speed of 40 kilometers per hour. Then he is traveling another 10 kilometers at a speed of 30 kilometers per hour. What is his average speed? See, whenever questions on average speed come, first thing that you need to know is, do not do it like this. 40 plus 30 by 2. That is how we take average generally. There are 2 speeds given, average of these 2 speeds is 40 plus 30 by 2. No, that's not how you calculate average speed. The formula for average speed is total distance traveled divided by total time taken. So here in this case the average speed will be what? Average speed is equal to total distance. What is the total distance? 20 plus 10 or 30 kilometers he has traveled totally. For the first 20 kilometers, how long is he taking? He is taking 20 divided by 40, right? See, 20 kilometers he is traveling at a speed of 40 kilometers per hour. So he will take half an hour to travel this distance. Next distance, 10 kilometers he is traveling at a speed of 30 kilometers per hour. Time that he takes for that will be 10 divided by 30, right? So this is going to be your average speed. See, I hope you understood what I have written here. 20 kilometers he is traveling at a speed of 40 kilometers per hour. So the time taken to cover this 20 kilometer distance is nothing but 20 by 40 hours. Correct? Next, the next distance, 10 kilometers he is taking, that is he is covering 30 kilometers per hour. So this 10 kilometers will be covered in 10 by 30 hours. So the total time that he takes will be, add these two, right? And the total distance that he travels is 30. So this answer will be your average speed. So this is how you calculate average speed. Okay, I hope the concept of average speed is clear to all of you. Is it clear? Shall I move on to the next concept? So never just find out the average like this. Okay, just don't add the speeds and divide it by the number of speeds that are given. Let's say there are 3 or 4 or 5. How much ever is given, just don't add them and divide by the number of figures given. Don't do that. That's not how you calculate average speed. Average speed is always equal to the total distance divided by the total time. The next concept that all of us should know is the concept of relative speed, a very, very important concept. So what is this concept of relative speed? See, whenever you have 2 moving objects that you consider, this concept of relative speed comes into play. That is, relative speed is nothing but the speed of one moving object with respect to another. Yes. Now, the concept of relative speed has a lot of applications. Our train problems, boats and stream problems, all of these are applications of this relative speed concept. So how do you explain this concept? How do I explain this concept to you? The best way to explain the concept of relative speed is something that we all have experienced. Okay, now all of you would have traveled by train. So assume that there are two trains, okay, who are going in opposite directions. There is a train A here and there is a train B here. Two trains are there traveling in opposite direction. Now many times, see, when we sit in the train, okay, suddenly at one point you will feel that your train has become stationary, and the train that is crossing you, let us say you are sitting on train A, okay, so I am sitting on train A, I am here. Now I am looking at the train B that is crossing me, okay. Sometimes suddenly what happens is I feel that I have become stationary and this train is moving really fast, okay, it is like zooming and going. Okay, sometimes you feel that way. There are other times wherein you actually feel that you are sitting on a train and there is a train which is overtaking you. Okay, I am sitting on this train again here, and there is another train which is overtaking me, but in a really slow way, right? Again, I feel that I am stationary and the train is going really slow and it is overtaking me. So these are some experiences I am sure all of us would have had. If you have traveled by train, you will definitely have this. And see, if you sit on this side, right, what I said you feel, when you look at this train, as I said, you will feel that this train is really slowly overtaking you and you actually feel that you are stationary. Similarly, when another train is crossing you and you are sitting on this side, suddenly you will feel that this train is going really fast and crossing you really fast, and again you feel that you are stationary. But when you look out of this window, no, you realize that you are actually moving. You can see open space here and you actually realize that you are moving. But when you look at this train here, you feel that you are stationary and this train is going really fast and you are not moving. Okay, all these that you feel, right, these are all effects of relative speed. So what happens in relative speed? See, if you have two objects, right, which are moving in the opposite direction, what happens is the speed of one object gets superimposed on the other object, and the net speed is nothing but the sum of the speed of these two objects. Okay, so that is what has actually happened here. So since you are sitting in this train A, let us say that your train is going at a speed of 40 kilometers per hour. This train is going at a speed of 60 kilometers per hour. Now when you sit here and look at this train going, you actually feel that this train is going at a speed of 100 kilometers per hour. How is that? That is the concept of relative speed. When two objects are moving in the opposite direction, the speeds of the two objects superimpose on each other and you actually feel the object is moving with a speed of 100 kilometers per hour. So remember, whenever you have questions on relative speed with two objects moving in opposite direction, if their speeds are s1 and s2, their net speed is nothing but s1 plus s2. Similarly, when two objects are moving in the same direction, right, this was opposite direction. Now here two objects are moving in the same direction. In this case, what happens is the net speed is nothing but the difference between the speed of the two objects. Okay, so if you have two objects moving in the same direction, the net speed is the difference between the speed of the two objects, where I am assuming s1 is greater than s2. Now again, let us consider this case, right? Here assume that your train is going at a speed of 40 kilometers per hour and this train is going at a speed of 60 kilometers per hour, because only if this train is going faster it can overtake you, right? If this train is slower than the train in which you are in, this train can never overtake you. That's why I have considered it like this. Now if this is the case, see, both the trains are moving in the same direction. Actually this train is moving faster than you, faster than your train, but when you sit here and look at this train, you will actually feel that this train is going only at 20 kilometers per hour. That's what you feel actually. When you sit here and look at this train moving, you will actually feel that it's going only at a speed of 20 kilometers per hour. Actually it is going at this speed. Again, why do you feel it that way? You feel it that way again because of the concept of relative speed that comes into play. So if there are two objects which are moving in the same direction, the net speed is nothing but the difference of their speeds. This is the basic concept of relative speed, and this is the best example in which you can remember it. See, it is something that all of us have experienced, right? So it can never go out of your mind and you can never make a mistake once you know this concept. I hope all of you agree with me on that. Yes, I am sure all of you would have experienced sitting on a train and seeing that, right? At least as children we would have enjoyed doing that, sitting on the window seat and seeing trains that cross you. Okay, so if you know this concept clearly, then the concept of relative speed is very, very easy. That's all what relative speed means. Okay, is it clear? Now let us look at the applications of relative speed. Generally, this concept of relative speed comes into play when you have problems on trains and boats and streams. So let's first look at problems on trains. So let us see how this concept of relative speed comes into play here. Anyways, I have already explained it with the help of an example to you, but again let us see in case of questions, in case of problems, how this comes into play. Okay, now see, you have two trains. Let us say there is a train of here and a train here. Now both these trains are moving in the opposite direction. This train, let us say, is moving with the speed of S1, this train is moving with the speed of S2, and we have to find out in what time both these trains will cross each other. Okay, now whenever question on trains come, we will have to take into consideration the length of the train. See, if the question is on a car that is moving, the length of the car is negligible, right? That needn't be considered. But when it comes to train is a very big vehicle. So you will have to take into consideration the length of it. So whenever you have questions on train, take into consideration the length. So if you have two trains A and B which are traveling in the opposite direction, and you have to find out in what time will they cross each other, where it is given that length of the train A is L1 and length of the train B is L2, then the time taken to cross each other is nothing but L1 plus L2 by S1 plus S2. Now how do I say this L1 plus L2? See, when do I actually say that these two trains have crossed each other? That's what. See, you don't mug up formulas directly. Understand why this formula has come. If you understand it, then you needn't remember the formula at all. It will automatically come to you when you solve questions. Again, when you know these, what happens is some questions which are twisted, right, and where you cannot directly use the formula, if these concepts are clear to you, you can apply those concepts and solve those questions also. That's why you need to know how these are arrived at. Now, when do I actually say that two trains have crossed each other? See, this is one train and this is the other train. At this point, both the trains are meeting. Now, both the trains will cross each other. So basically, this end of the first train, right, this end of the first train, let us take it as this point, point 1, should actually come here, or basically it has to cross from here till here, right? So similarly, if you are considering this train, okay, this point here has to come from here till here, or basically this one point has to cover this total distance of L1 plus L2, that is the length of the first train plus the length of the second train. So that's how you say that the total distance travelled is L1 plus L2. See, take any one point in any one of the train, any one train you can consider. If I am considering this point, that is, this is the last end point of this train, right? This point of this train should reach here, and the distance that it has to travel to reach here is L1, that is the length of this train plus the length of this train. Or if you are considering it the other way, this point, no, this last point here should reach here, again L2 plus L1. So that is how you say the time taken should be equal to L1 plus L2 divided by S1 plus S2. The length plus the total length plus the total, the speeds, net speeds, because they are traveling in opposite direction, relative speed is sum of their speeds. Similarly, if you have two trains which are traveling in the same direction. Now this case that we saw is for trains traveling in opposite direction. The next case is wherein two trains are traveling in the same direction with speed S1 and S2. How long will they take to overtake each other? One train is of length L1, other train is of length L2. The total time is nothing but L1 plus L2 divided by S1 minus S2. That is the faster speed minus the slower speed. So net speed is difference between the speed of the two trains. That will be the time taken to cross each other. So this is how you go about when you solve questions from trains. Again, in trains, sometimes, many times they will ask you what is the time taken by the train to cross a pole. Yes, so in such cases, whenever they are asking you, there is a pole here, what is the time taken by this train of length L1 whose speed is S1 to cross this pole? Whenever the question has something like a pole or a car or something which has negligible length, right, in those cases don't take into consideration the length of the object. So here you will just say that the time taken will be the length of the train divided by the speed of the train. Yes, and again let us say that there is a train which is crossing, there is a man who is running in this direction, there is a train also which is running in this direction. This man is running at a speed of S2. Now again, what is the time taken by the train to cross this man? Again here you needn't consider the length of the man, right, because it is negligible. It's like a point, right, compared to the train. So the time taken will be the length of the train divided by the relative speed here. In this case, when it is a pole, the pole doesn't move, right? So you didn't consider the speed of the pole. But here the man is running with a speed of s2 in the same direction as the train. So the net speed will be L1 divided by S1 minus S2. This will be the time taken by the train to cross the man, or cross the man, S1 minus S2, because both of them are traveling in the same direction. Again, there will be some other type of questions will include a train crossing a platform, right? Again, when it comes to platform generally has some length that they give, right? The train has a length L1, and let me assume that this is a platform and the train is traveling at a speed of S1. What is the time taken by the train to cross the platform? It is nothing but L1 plus L2 divided by S1. Here platform is stationary, only train is moving, so speed is S1. When you look at length, the length of the platform is comparable, so the length of the train plus the length of the platform. Again, if the train has to cross the platform, what does that mean? See, you have a train here and you have a platform here, right? This is the platform, this is your train. Now the train has to cross this platform, means this is L1, this is L2. Yeah, the train has to cross the platform means this point of the train, right? This end point of the train should come here. So what is the distance that the train has to travel? It has to travel this length L1 plus the length of the platform L2. So that's how we get L1 plus L2 divided by S1. So that is the concept of trains. I think I've covered all the types of questions that you can expect from this. So as I said, whenever question on train comes, try to take into consideration the lengths of the train. When there is a pole that comes, you needn't take into consideration the length of the pole, like the length of the pole or a person. Only if the object is moving, take into consideration the speed of the object when the length of the object is negligible. Then you have questions wherein you have platforms involved, wherein you will have to consider the length of the platform. This is the concept of trains. Moving on, the next most important concept that you need to know is the concept of boats and streams. Yes. So boats and streams, the concept is like this. See, you have a river which is flowing. Yes. Now the water in the river is flowing with some speed. So let me take the speed as y kilometers per hour, or this is the speed of the water current that is flowing, and the water always flows in one particular direction. Now you are going on a boat in this river. There are two ways in which you can go. Either you can go in this direction. Now this direction is called as downstream, because you are going in flow with the river, correct? You are going in the same direction as the water current is flowing. So this case is called as downstream. And I am assuming that your boat, when you are in a still water where the water is not moving at all and the boat is only moving, or I can say that the actual speed of the boat, if it is x kilometer per hour, then the net speed, right, or the speed at which with which the boat will move now when it is moving downstream where the river is flowing at a speed of y kilometers per hour is nothing but x plus y. Right, this will be the net speed of the boat downstream, or the speed downstream. Net speed is nothing but x plus y kilometers per hour. See, I have just written kilometers per hour here. Sometime questions will also be in terms of meter per second. I have just taken one unit for now and I am representing everything in terms of that. Now the next case is wherein the river is flowing in this direction and the boat, right, this is going at a speed of y kilometers per hour. The river or the water is flowing at a speed of y kilometer per hour and your boat is going against this flow, right? So the speed of the boat when there is no water current is x kilometers per hour, and what will be the net speed of the boat when it is going against this water current? This case is called as upstream. Okay, this means that the boat is going upstream or it is going against the flow of water. So here the net speed SU is given as x minus y kilometers per hour. Why is it x minus y kilometers per hour? See, the boat is overcoming the speed of the water current. Here the water current helps the boat to move even faster. So that's why you take x plus y. Here the boat is going against the flow of water. So it has to overcome the speed of the water current. So the net speed is nothing but x minus y kilometers per hour. See, this is one concept which should be very clear to you in your mind, because when we actually do train problems, what do? Two objects moving in opposite direction, we add their speeds. Two objects moving in same directions, we subtract their speed. But if you see here, upstream and downstream, it looks like a bit different, but understand what is the concept involved. When the boat is moving in the same direction as the water current pushes the boat further, right? So that's how you add up the speeds. Now when the boat is going against the water current, what is happening? The boat has to push against the water flow and overcome that and go further, right? So that is why you are subtracting and getting the net speed as x minus y kilometers per hour. So everything else, concept wise, everything else is the same. Just these things you need to be clear about. You will be able to solve questions from this topic. Yes, so I hope all the concepts that we discussed is clear to you and there is no doubts in any of the concepts that we discussed. So I think a very minor concept left out to be discussed is problems involving circular tracks. So what we'll do is we'll discuss that concept as and when the question comes on circular track, and then again on races, okay, concept of races. So that also we'll discuss when we solve questions on that. Right now we'll start solving the questions. Okay, first question, a very basic question. So I want the answer for this question in like 2 to 3 seconds. That's all is required because I just took this question to start, right? We'll start from basics and then move on to difficult ones. What is given here? A boy goes to school with a speed of 3 km an hour and returns with a speed of 2 km per hour. If he takes 5 hours in all, find the distance in kilometers between the village and the school. What is given here? A boy is going to a school. Yes, so this is the boy's house, let's say, and he is going to the school and he is coming back. So let us assume that the distance between the school and the house is x kilometers, and he is going from the house to the school at a speed of 3 km per hour, and when he is coming back with a speed of 2 km per hour. Now what is the time taken by the boy to go to school? It is nothing but x by 3, that is distance divided by time. What is the time taken by the boy to come back from the school? X by 2, right? Distance is x, speed is 2. So put together, what is the total time that he has taken? It is nothing but x by 3 plus x by 2, and it is given here that it takes 5 hours in all to do this, right? To go and come back, or this is equal to 5. Now what is the question? Find the distance in kilometers between the village and school. Find out the value of x. So when you solve, you get x is equal to 6 kilometers. Yes, a very basic question on time and distance where you just use this formula, speed into time. So here, as I said, first we'll have to see what are the units here that all correct here. So not much calculations involved. So this is how you basically solve such a question. Yes, next question. So this is a very typical type of question that comes in time, speed and distance. Let us look at this one. Walking with 6/5 of my usual speed, I reach my office 10 minutes too early. Find my usual time. What is given here? Walking at 6/5 of my usual speed, I am reaching 10 minutes early. So first let me assume that the actual distance to my office, let that be d. Okay, or okay, instead of d, let's take it as x. Let us take the distance to my office is x kilometers, and the normal speed with which I travel to my office is s, and the time that I take usually is t. So what can I say? I can say x is equal to s into t. So I travel with certain speed, I take certain time to reach my office. Now what has happened? This same distance, right, this x kilometers, I am traveling with a speed of 6 by 5 s, correct? I am traveling at 6/5 of my usual speed, and in what time am I reaching? I am reaching my office 10 minutes too early. Okay, so 10 minutes too early means I am reaching 10 minutes ahead. So if I am usually taking t minutes, now I am only taking t minus 10 minutes, right? So again here, see, again whenever questions like this come, right, see here in terms of minutes is given, generally we always use either meter, second or kilometer per hour, right? Meter, second, kilometer, hour. This is the standard unit that we will be following generally. So here if it is 10 minutes, you can actually take it as how many seconds? Let us try and solve everything in terms of seconds. So you can say 10 minutes is nothing but 10 into 60 or 600 seconds, right? So what is happening here? When my speed is becoming 6 by 5 of s, I am taking t minus 600 seconds to reach the office. Or I can say that is what distance divided by speed is equal to time. We know this, right? So here x divided by 6 by 5 s, that is equal to t minus 600. Now I know already here from this equation I can say s is equal to, t is equal to x by s. So here this x by s I can replace it by t. So I can say t by 6 by 5, that is equal to t minus 600, or take this up, 5t by 6 is equal to t minus 600. So when you solve this, actually you get t is equal to 3600 seconds. So 3600 seconds is nothing but 3600 by 60, that is equal to 60 minutes. Yes, that is the answer that we are looking at. Now for this particular question, you need not actually convert. You can directly take it as 10 minutes and solve, because no other terms are involved, right? In the sense we are not taking speed in terms of meters or x in terms of meters. Nothing like that is done, right? Speed in terms of meters per second or x in terms of meters. So here if t is in terms of minutes, only t we are considering. You can actually continue to solve it in terms of minutes itself, so that you needn't do this extra conversion. But I just did this so that you will always have that in mind, that units have to be standardized throughout the variable. For this particular question, we are making use of only t, correct? The only variable that we are looking at is t. Everything else is in terms of s and x, and you are not actually having any values. So directly itself you can solve. I hope it is clear. A very easy one and a very typical type of question that comes from this topic. So the correct answer here will be option B, 60 minutes. See, I hope it is clear. We know the distance x is equal to s into t. Now they are saying that he is traveling with a speed of 6 by 5s and the time taken is so much. So what do I do? See, I just equate, right? See, I know d by s is equal to, I have to find out time. So here I know x by s is equal to t. That is one equation that I have. And the next equation that I have is here x is the same, my speed has become 6 by 5s. In that case, what is my time becoming? My time is becoming t minus 60. I took it as 600 because I converted in terms of seconds. Actually not required. You can directly do it in terms of minutes also. You will directly get the answer in terms of minutes. So you have two equations here. Solve for this and get the value of t. That's all. Next question. Sound travels 330 meters a second. If the sound of a thundercloud follows the flash after 10 seconds, the thundercloud is at a distance of dash. What's the answer for this one? Try this one and give me the answer. Again, an easy one. All these questions are using very, very basic concepts of time, speed and distance. Sound travels 330 meters per second. So speed of sound, right? It is 330 meters per second. Now, if the sound of the thundercloud follows the flash after 10 seconds. So how long is the sound of the thundercloud taking to come? It is taking 10 seconds to reach us. Yes? Now the question is, what is the distance of the thundercloud is at dash. Now fairly easy question. See, there is a lightning. Okay, let us say this is a lightning. You have a lightning here and you are here, right? You are here. Now for this cloud to, this sound to reach you, okay, it is taking 10 seconds. The question is, what is the distance from you to this thundercloud? Very easy, no? We know that sound is traveling at a speed of 330 meters per second and it is taking the sound 10 seconds to reach you. So what is the distance between you and the thundercloud? It is nothing but 330 into 10. That is the speed into the time taken. That will be the distance, or that is equal to 3300 meters, or that is equal to 3.3 kilometers. Very, very easy question. Don't get worried about the terms that are given here like sound, thundercloud and all. Very basic question. Yes, so the correct answer here is option C, 3.3 kilometers. Next one. Nikita starts her journey from Delhi to Bhopal and simultaneously Nishita starts from Bhopal to Delhi. After crossing each other, they finish their remaining journey in 5 4/9 hours and 9 hours respectively. What is Nishita's speed if Nikita's speed is 36 kilometers per hour? So give me the answer for this one. What is given here? Nikita starts her journey from, there are two places, Delhi and Bhopal. Nikita is here, right? Nikita is starting from Delhi to Bhopal, and same time Nishita is starting from Bhopal to Delhi. Now at some one particular point they are meeting. Let us say at this point they are meeting. After crossing each other, they finish their remaining journey. That is, Nikita from here will take 5 4/9 hours and Nishita from this point will take 9 hours to reach. Now it is given that Nikita's speed is 36 kilometers per hour. What is the question? You have to find out what is this one's speed. What is Nishita's speed? So actually to solve this question, see if you do it using the conventional way, it's going to take some time, right? We know the speed of Nikita is 36 km per hour in 5 4/9 hours. What is the distance that she will travel and all that you find out, right? And then that's how you solve it in the conventional way. But whenever such a question comes, there is a shortcut formula that you can keep in mind, okay, to approach such questions. So that's why I've actually taken this question to let you know what the formula to be used is. See, if you have two people in the given question, there are two people A and B, right, who start from two different points at the same time, and there are two people A and B, and let us say A is starting from a point P and B is starting from a point Q. Okay, they are moving towards each other and they meet at some particular point here. Okay, after they meet, this A is taking T1 hours to reach Q, and after meeting, this B is taking T2 hours to reach A. Then you can say that this A's speed, okay, divided by B's speed. The speed or the ratio of speeds of these two people is nothing but T2, root of T2 divided by root of T1. So many times if you know this formula, this question answer, you will get it in one step. Okay, so these are see, these are very few formulas like this I would want you to remember, because remembering too much formulas is also a pain. In the examination you will tend to forget which formula for what and all that, but this is a fairly easy one to remember. So the ratio of, if there are two persons A and B who are starting at the same time from 2 points P and Q, and they are moving towards each other, and after crossing, if they take time T1 hours and T2 hours respectively to reach their destination, you can say that A's speed divided by B's speed is equal to root of T2 by root of T1. So here in this case, speed of Nikita divided by speed of Nishita, that is equal to root of time taken by Nishita after they meet. What is the time taken by Nishita after they meet? That is 9, divided by root of T1, that is the time taken by Nikita after they meet, that is 5 4/9. Here already you know speed of Nikita is 36 by speed of Nishita. So here what do you get? Speed of Nishita is equal to 36 into root of 5 4/9 is how much? 9 5s are 45 plus 4. Root of 49/9 divided by root of 9. So here you have 36 into root of 49 is 7. 7 by 3, you will have another 3 here. So 4. This is 9. 36 by 9 is 4. So 7 4s are 28. So her speed is 28 kilometers per hour. The correct answer here is option C. Hope it is clear. Next question. Try out this one. Without any stoppage, a person travels a certain distance at an average speed of 42 kilometers per hour, and with stoppage he covers the same distance at an average speed of 28 kilometers per hour. How many minutes per hour does he stop? See, how do you approach this question? In general, let us take some distance, okay, which is with which you can take it as a base and then go about solving the question. See, here you have two figures, right? First he was traveling at a speed of 42 kilometers per hour. With stoppage he is traveling at a speed of 28 kilometers per hour. So I just want some figure number which is a multiple of these two to be taken as the distance that the person travels, so that my calculation becomes easier. So I am just going to assume that what is the LCM of these two numbers? See, 28 and 42, their LCM will be 84, right? 28 into 3 is 84. I am just looking at a multiple of these two numbers. Similarly, 42 into 2 is 84. So I am just going to assume that the total distance that is travelled by the person is 84 kilometers. Now, see, you can assume any value. I am taking a value like this, which is an LCM of these two numbers or a multiple of these two numbers, so that calculations become easier. So I am just assuming that this person is going to travel 84 kilometers. Normally, how long is he taking to travel this 84 kilometers? That is without stop. Right, without stopping, if he is traveling this 84 kilometer, he will take 84 divided by 42, or he is going to take 2 hours. Now, with stopping, right, he is stopping in between, we don't know for how long. When he is doing that, how long is he taking? 84 by 28, or he is taking 3 hours. So a thing which was a distance which actually he was covering in 2 hours, now he is taking 3 hours to cover. So where does this extra 1 hour come from? This extra 1 hour is his stopping, right? Stoppages in between, right? What are they saying in the question? Every 1 hour he is stopping for some time, and that's how totally it is becoming 3 hours of journey. That is totally in this 3 hours, 1 hour is his stoppage time. Total 1 hour is the stoppage time. So if you look at every hour, what is the time that he has been stopping? He has been stopping for 1/3 in every hour. Correct? 1/3 of an hour. 1/3 of an hour is how much it is? 20 minutes. Correct? See, totally in 3 hours, right? Totally 1 hour he has stopped. So in 1 hour, how much he would have stopped? He would have stopped 1/3 of an hour. What is 1/3 of an hour? 60/3, that is equal to 20 minutes. So every 20 minutes he is stopping. I mean, so that is not every 20 minutes he is stopping. In every 1 hour he is stopping for 20 minutes. Next one. So this one is on trains. 2 trains starting at the same time from 2 stations 200 kilometers apart, going in opposite direction, cross each other at a distance of 110 kilometers from one of them. What is the ratio of their speeds? So you have 2 trains coming from 2 different stations which are 200 kilometers apart, and they are crossing each other at a distance which is 110 kilometers from one of the stations. So I am assuming that they are crossing, this is station A and this is station B. So let us assume that they are crossing each other 110 kilometers away from station A. So what is the distance away from station B? 90. Now what is the ratio of their speeds? So here see, to reach this particular point, right, this is the point where both the trains are meeting. Now let us assume that the speed of the train that starts from station A is S1 and the speed of the train that starts from station B is S2. What is given here? They are meeting at some point here. Now the time taken by both the trains to reach this point is the same. That's correct. See, both the trains are starting simultaneously from A and B and they are meeting at one point. So the time taken by both the trains to reach this point is going to be the same. What is the time taken by this train which is starting from station A to reach this point? It is nothing but 110 divided by S1. The distance it travels divided by the speed at which it is going. Similarly, what is the time taken by the second train that is starting from B to reach this point? It is nothing but the distance that it travels divided by the speed with which it travels. We know this time that takes by both of the trains is the same. Equate this, what do you get? 110 by S1 is equal to 90 by S2. What is the question that they have asked you? What is the ratio of speeds of the 2 trains? So ratio of the speeds is nothing but 110 divided by 90, that is equal to 11 by 9. Option C. Yes, very easy question, no? Yeah, so that's the answer for this one. Now let us look at the next question. 2 trains A and B 100 meter long are moving on parallel tracks at a speed of 20 meters per second and 30 meters per second respectively. They are travelling in opposite direction. A boy in front of train A sees another boy in front of train B when he is closest to him. He throws a ball at a speed of 2 meters per second which hits the tail of train B. What is the distance between the 2 trains? So let's solve it. See, you have 2 trains A and B 100 meter long. So there are 2 trains moving in the opposite direction, right? One train is going in this direction, the other one is going in this direction. Length of the train is 100 meters. One is going with a speed of 20 meters per second. The other one is going with a speed of 30 meters per second. Now there is a boy who is standing here in front of this train A, okay, and he is looking at a boy who is in train B, right? Now what is given here? A boy in front of train A sees another boy in front of train B when he is closest to him. So when will both these boys be closest to each other? When the trains are like this, right? See, the first train A is like this, at the same time train B is like this. Then only these 2 people are close to each other. As these trains move apart, these 2 boys will also, their distance between them will keep increasing, right, as the trains keep moving apart. So both the boys will be closest to each other when the trains are like this, at this point, okay, when they are just meeting. Now at this point, what is this boy from train A doing? He is throwing a ball, and this ball is going and hitting the tail of this train. So this boy is throwing a ball which is hitting the tail of the train B. Now they are asking what is the distance between the two trains. Basically you have to find out what is the distance between the two trains. Now here, see what happens. Two trains are moving in the opposite direction. So actually what is the net speed at which this boy is actually moving now? See, he is only moving at 20 meters per second, right? That is the speed at which the train is going. But here this train is coming in the opposite direction at a speed of 30 meters per second. So what can you say? The net speed of the boy, right, or the relative speed of the boy is equal to 20 plus 30 or 50 meters per second. Right, net, because the boy is also having a speed. Why am I saying boy is having a speed? He is on a train and the train is moving. That is equivalent to saying that the boy is moving at a speed of 20 meters per second. There is a train that is coming in the opposite direction at a speed of 30 meters per second. So net, the relative speed here is 50 meters per second. Now what is happening to the ball? He is throwing a ball at a speed of 2 meters per second, and this ball has to hit here. So if you look at the ball has to start from this point, right, and go till this point, or the ball has to cover this 100 meters. Okay, ball has to cover a distance of 100 meters. Now what is the relative speed? As I said, the relative speed here is 20 plus 30 or 50 meters per second. So in what time will this ball cover this 100 meters? It is nothing but 100 divided by 50, or in 2 seconds the ball will cover this 100 meters. I hope it is clear. See, what I am trying to say here is that this boy is throwing a ball. Now what is happening? This ball has to cover from this end till this end, or the ball has to travel a distance of 100 meters, and the speed of this train, or the train in which the boy is going, is 20 meters per second, and the speed of this train which is traveling at a speed of 30 meters per second, in this direction, is 30 meters per second. So the relative speed, or the net speed, or the time taken by these two trains to cross, that is the relative speed between these two trains, is 50 meters per second. Or I can say that this ball from here to reach here, what is the time that it will take? 100 divided by 50, that is the distance that it has to travel divided by the relative speed between the trains. Or the ball will reach from this point to this point in 2 seconds. Now it is given in the question that the ball is thrown with a speed of 2 meters per second. So 2 meters per second means in this much time, what is the distance that is travelled by the ball? 2 into 2, that is equal to 4 meters. So what is the distance between the two trains? It is nothing but 4 meters. That is option C. I'll explain it once again. See what is given here. There is a boy standing here. Okay, when these two trains are in this, like this, right, they are just meeting each other. This boy is throwing a ball. You have to find the distance between these two trains. Now what is happening is this ball has to come from here till go to this here, correct? So the ball actually has to travel a distance of 100 meters, that is equivalent to the length of the train B. Now this, to travel this 100 meters, what will be the time taken? See, both the trains are moving in the opposite direction, so the relative speed is nothing but 20 plus 30 or 50 meters per second. So the ball will travel 100 meters in 100 by 50 or in 2 seconds. Now it is given that the ball is thrown at a speed of 2 meters per second. So if the ball is thrown at a speed of 2 meters per second, the total distance that is travelled by the ball is 4 meters. So only that has to be the distance between the trains. Answer is option C, 4 meters. Next question. Two cars start together in the same direction from the same place. The first goes with uniform speed of 10 kilometers per hour. The second goes at a speed of 8 kilometers per hour in the first hour and increases the speed by half kilometer each succeeding hour. After how many hours will the second car overtake the first if both go non-stop? See, this question can be solved in two ways. Either you can write it down in form of an equation and find the sum to n terms and then solve it. The other way is to just write down the distances between both the car at the end of each hour and equate that. Okay, so see what is given here. Two cars start together in the same direction at the same place. So let us take the two cars as A and B. So A was going 10, 10, 10, 10. This is first hour, third hour. Here you have 8, 8.5, 9, 9.5. okay, then you have 10, 10.5, 11, 11.5 and so on. So this is 3rd, 4th, 5th, 6th, 7th, 8th and 9th, correct? Yeah, so if it is like this, then 1.5, then 1, then 0.5. So at this point, right, it is 0. At the 5th hour, it is 0. So B will start going faster than A only after this point. Okay, here at the 6th hour, A will keep doing 10 only every hour. A is doing only 10 every hour. B keeps on increasing. So next it will be 0.5, 1, 1.5 and so on. So this distance, right, that has to be covered, that is lagging. B is lagging behind A by so much distance, right? 2 plus 1, that is 3 plus 1.5 plus 5. So 3 plus 2, that is 5. So 5 kilometers B is lagging. In how long is he going to make it up? So he will make it up in, here you have 0.5, 1, 1.5 and 2 here. So when you add these, again you get 5. 2 plus 1, 3, 5. So in the 9th hour, right, after 9 hours, as soon as he completes 9 hours, he will start overtaking A. So the correct answer here for this question will be 9 hours. See, when you write it down, don't make mistake like I did. It's a very easy one actually. If you just write this table correctly, it's very easy to solve. Now the other way to look at this question is like this. See, assume that the car A, okay, there is car, you have cars, right, A and B. Assume that B takes n hours to overtake A. So in this n hours, what is the distance that is travelled by A? A would have travelled 10 n. Every hour A is travelling 10 kilometers. So in n hours, A would have travelled 10 n kilometers. Now in this n hours, what is the distance that is travelled by the car B? First hour it will travel 8 kilometers. Next hour it will travel 8 plus 1 by 2. Next hour it will travel 8 plus 2 by 2. Next hour it will travel 8 plus 3 by 2 and so on till 8 plus n minus 1 by 2 for n hours, right? So you can equate these and also solve and find out the value of n. So this is the other way in approach this question, but I felt this is a more easier way, right? This is the easier logic. You can just put in the values there and solve. Okay, I hope it is clear. For the first 4 hours, if you see, every hour B is lagging behind A by some kilometers, right? 2 kilometers in the first case, 1.5 kilometers in the second case and so on. So totally at the end of the 4th hour, A is lagging behind B by 5 kilometers. Now from the 5th hour, both of them are traveling the same distance, and from the 6th hour, B starts traveling more distance per hour. So to make up for this lag of 5 kilometers, this car B is going to take till the end of the 9th hour. So at the end of the 9th hour, by increasing the distance that he is traveling for every hour, the car B will overtake car A. Now it will come in it will cover the same distance as car A, and at the end of the 9th hour it will overtake. So the correct answer here is option A. I hope it is clear. Clear, no? Next question. Vaibhav can walk up a moving up escalator in 30 seconds. He can also walk down this moving up escalator in 90 seconds. If his walking speed is same, upwards and downwards, then how much time will he take to walk up the escalators when the escalator is stationary? The escalator is actually moving up, right? The escalator is moving up and Vaibhav can walk up in this moving up escalator. So, see, escalator is going in this direction. This is the escalator and this is Vaibhav, okay? So, he can move up a moving up escalator in 30 seconds. So, let me assume that x is the speed of Vaibhav, x meters per second. And let us assume that y is the moving up speed of the escalator. So, Vaibhav is taking 30 seconds to move up this escalator. Now let me assume that the total length of the escalator, let that be d. So what can I say? I can say distance travelled divided by the net speed bit of Vaibhav and the escalator is now x plus y. So d by x plus y, that is equal to 30. So Vaibhav takes 30 seconds to move up a moving up escalator. Now next, what are they saying? Vaibhav can walk down right? When escalator is going up, Vaibhav is now walking down or going against the escalator, right? So see again, see this is also a question on relative speed, but understand the question here. What is Vaibhav now doing? Earlier, Vaibhav is going up on a moving escalator. So what will happen? Vaibhav's speed will also increase, right? Escalator is moving in one direction. Vaibhav is also going up in the same direction, means Vaibhav's speed and the escalator speed will add on. And the net speed is nothing but x plus y, right? It's just like the boats and the stream, right? The water current will push the boat further. Similarly, the escalator speed will give Vaibhav further speed to go up faster. Now, when Vaibhav is going against the escalator, what will happen? His net speed will reduce, right? So, now the time taken by Vaibhav, escalator is going up, he is coming down. So, now the net speed for Vaibhav to come down is nothing but x minus y, because Vaibhav is going against the movement of the escalator. So, he has to overcome the speed of the escalator to come down, and this is given as 90. Now, what are they asking you? You have to find out the time that Vaibhav takes to walk up the escalator when the escalator is stationary. So, with these two equations, what can I say? I can say x plus y, that is equal to d by 30, and I can say x minus y, that is equal to d by 90. So, if I subtract these two equations, right, equation 1 and equation 2, if I subtract them, what do I get? I'll get, no, if I add, let me add. So, I will cancel out y, right, because I need only x, because I need to find out the time taken by Vaibhav to walk up the escalator when it is stationary. So, let me try to cancel out this y. So, I get 2x is equal to d by 30 plus d by 90, or I can say x is equal to 1 by 2 into, you take the LCM here, you will get 3d plus d by 90, or that is equal to 1 by 2 into 4d by 90, or that is equal to 2d by 90, that is equal to d by 45. So, what do I get? I get x is equal to d by 45. So, what is this x? X is nothing but the speed of Vaibhav. So, I can say x is equal to d by 45 meters per second. Now, what is the question? How long will Vaibhav take to walk on the escalator when the escalator is stationary? When the escalator is stationary, it's very easy. You know, escalator is just there. It is just a distance that Vaibhav has to cover, and the length of the escalator is d. And the speed of Vaibhav, you know, it is this. So, what is the time that Vaibhav will take to go through the escalator now? D divided by d by 45. The distance divided by Vaibhav's speed, or that is equal to 45 seconds. The correct answer here will be option B. I hope it is clear. I will explain it once again. See what is given here. There is an escalator which is moving up, and it is given that Vaibhav, if he is walking on the escalator and moving up along with the escalator, he will take 30 seconds to cross the escalator. Now, if the escalator is moving up and Vaibhav is moving down, he will take 90 seconds to come down. Now, why is this difference between, why is this 30 seconds and 90 seconds? See, when the escalator is going up and Vaibhav is also going up, the net speed is nothing but the sum of the speed of the escalator and Vaibhav. So, I can say the distance travelled divided by the net speed, that is equal to the time taken. So, that is how we get the first equation. Similarly, when Vaibhav is coming down and escalator is going up, means Vaibhav has to come against the speed of the escalator and come down. So, d by x minus y is equal to 90. So, from this I tried to get the equation in terms only of x, that is the speed of Vaibhav, and I get x is equal to d by 45. Now, the question is, when the escalator is stationary, what is the time taken by Vaibhav to cross it? So, time is nothing but distance divided by speed. Speed I have found out in terms of d. I get the answer as option B, 45 seconds. Next one. The next question is on boats and streams. Total distance between A and B is d kilometers. If the distance travelled along the stream is 3 times of the total distance, and the distance travelled against the stream is 2 times of the total distance. Okay, if the time taken to cover the distance along the stream is 10% less than the time taken to cover the distance against the stream, if a person covers a distance of 21 kilometers in 1 hour 24 minutes along the stream, then find the rate of current. Lot of information given, right? So let us first look at this. What have they said? A person travels 21 kilometers, okay, in what time? 1 hour 24 minutes. Now here look at the options given. Options is in terms of kilometers per hour. So let us convert everything into kilometers and hours. Here 1 hour 24 minutes is how many hours? 1 hour plus 24 by 60, right? That is minutes in terms of hours. So 24 by 60 is how much? 6 4s are 24, 10. 4 by 10, or that is 2 by 5. Or I can say this is 1, 2 by 5, that is equal to 7 by 5 hours. Correct? So it is, I know that a person covers 21 kilometers in 7 by 5 hours along the stream. So here again, along the stream means I am assuming the water current, okay, is flowing at a rate of y kilometers per hour, and this person is traveling at a rate of x kilometers per hour. So along the stream means along with the water, right? So net speed is nothing but x plus y. So now I know the distance travelled divided by the net speed, that is x plus y, that is equal to 7 by 5. So this is one equation I have. So from this I can say x plus y, that is equal to 15. Okay, so I have got this. Now look at the first statement that is given. What have they said? Total distance between A and B is d kilometers. So there are two places, A and B, distance between them is d kilometers. Yes. So let us say water is flowing in this direction. Now if the distance travelled along the stream is 3 times the total distance, and the distance travelled against the stream is 2 times the total distance. So if I have to go downstream from A to B, okay, now if the distance travelled along the stream is 3 times of the total distance and the distance travelled against the stream is 2 times of the total distance, and if the time taken to cover the distance along the stream is 10% less than the time taken to cover the distance against the stream. So what they are trying to say is the person is actually travelling 3 times d, okay, downstream, and he is upstream he is travelling 2 times d, and now they are saying that to cover the time taken to cover the distance along the stream, right, to travel this distance of 3d, this person is only taking 10% less than the time taken to travel this 2d upstream. Now to make it more clear, see, if the person is going to travel, see there are 2 places A and B, between them the distance is d. Now if the person is travelling 3 times this distance downstream, what will be the time that he takes to travel that? It will be 3d divided by x plus y. This is the time that he will take to travel downstream, this so much distance. Similarly, what will be the time that he will take to travel 2 times this distance upstream? It will be 2d divided by x minus y. Now what have they given here? They have given here that this time taken to travel this distance 3d by x plus y is equal to 10% less than the time taken for this, or that is, this is equal to 90 by 100 of 2d by x minus y. So basically if you equate this and you solve for this, you will get, you have 10 into x minus y, that is equal to 6 into x plus y, or you can say 10x minus 6x, that is 6 into x plus y. Yes, you have 5x minus 5y is equal to 3x plus 3y, or x is equal to 4y. You get x is equal to 4y, right? Yeah, you have 4x, that is equal to 10 plus 16, 16y, or I can say x is equal to 4y. So this is the relationship between x and y that I have got. Now I know here x is equal to 4y. I have already framed an equation which says x plus y is equal to 15. Substitute this here and find out the value of y. So x is equal to 4y means what will I get? 4y plus y, that is equal to 15, or y is equal to 3 kilometers per hour. What is the question? What is the rate of the current? Rate of the current is y, 3 kilometers per hour. See, the question, lot of information is given, so it might sound a bit confusing. I'll explain once again what I have done. See, in the last sentence they had given that a person covers 21 kilometers in 1 hour 24 minutes along the stream. So 1 hour 24 minutes is, I converted that into hours. So 21 kilometers he is covering in so much hours. See, again it is downstream. So downstream means speed of the person plus speed of the stream I have taken. Now next what they are saying is that, see actually this and all is not required, right? They have given lot of statements to confuse us, but what they are trying to say here is that if a person is traveling a distance of 3D downstream and he is traveling back a distance of 2D upstream, and to travel this distance of 3D downstream he takes only 90% of the time that he has taken to travel this distance 2D upstream. So that is what you are equating. So first I found out what is the time that he takes to travel this distance 3D, that is nothing but 3D divided by x plus y. What is the time that he takes to travel this distance 2D upstream, that is nothing but 2D by x minus y. So I am just equating here this 3D divided by x plus y, or the time taken to travel this 3D distance downstream is equal to 90% of the time taken to travel this 2D distance upstream. So from this I found out the relationship between x and y, put it here and found out the value of y. Correct answer is option B. Next question. Two cyclists start on a circular track from a given point but in the same directions with speeds of 7 meters per second and 8 meters per second respectively. If the circumference of the circle is 300 meters, after what time will they meet for the first time? Now, so the next we are moving on to questions on circular track. So generally when you have questions on circular track, you can have two cases. Let us assume that you have a track of length L and you have two people moving at a speed of A meters per second and B meters per second. Okay, let us assume that the track length is L meters. Okay, you have a track length of L meters, two people moving at one person moving at A meters per second and one person moving at B meters per second. You can have two possibilities. First possibility is where both people are going in the same direction. Say two people A and B are there. They are the ones who are moving at these speeds. If both the people are going in the same direction. Yes, so when will they meet for the first time? They will meet at length divided by relative speed between them. Since both of them are moving in their same direction, relative speed is nothing but difference between their speeds. So the first time that they will meet is L by A minus B. Okay, first time they meet is L by A minus B. Now sometimes in the question they'll ask, what is the first time, when will they meet at the starting point again? Okay, now there are two people who are running around a circular track of length L meter with speeds A meters per second and B meters per second traveling in the same direction. When will they meet again at the starting point? So whenever you have questions of that sort, you have to find out the LCM of the time taken by both of these people, right? LCM of time taken by A to cover the track and time taken by B to cover the track. LCM of these two values will give you when these two people will meet again at the starting point. Similarly, there can also be another case where this is one case, right? Both of them are moving in the same direction. Now, if both of them are moving in the opposite direction, let's say A is moving in this direction, B is moving in this direction. That is the next case, right? So you have a circular track here, one person going like this, one person going like this. So again, what is the first time that they will meet in this case? This is the case 1, this is your case 2 when it comes to circular tracks. So if they are moving in opposite direction, the first time that they will meet is nothing but L by A plus B. The length of the track divided by the sum of their speeds, because they are moving in the opposite direction. Now in this case also, when will they meet for the first time at the starting point? That remains the same, that is nothing but the LCM of the time taken by A to complete this track and the time taken by B. LCM of that, they will meet at the starting point. Again at the starting point. So this will be the time, okay? They will meet exactly at the starting point after so many seconds or hours, whatever in terms of it is given. Yes, LCM of the time taken by both of them separately. That will give you the time after which they will meet again at the starting point. So these two things keep in mind when you have to solve questions on circular tracks. Now let us look at this question. Two cyclists start on a a circular track from a given point but in the same direction with speeds 7 meters per second and 8 meters per second respectively. So 7 meters per second, 8 meters per second respectively. Circumference or the length of the circle is given as 300 meters. What time will they meet for the first time? That is nothing but 300 divided by relative speed between them, 8 minus 7. That is equal to 300 seconds. So they will meet again after 300 seconds. That is option C. Yes. Next one. Look at this question. Speed of a boat is 25 kilometers per hour in still water and the speed of the stream is 5 kilometers per hour. If this boat takes 15 hours to go to a place and come back, the distance of the place is dash. A very basic question from boats and streams. What is given here? Speed of the boat is 25 kilometers per hour in still water. Speed of the stream is 5 kilometers per hour. Boat takes 15 hours to go to a place and come back. So if the boat is starting from here, going here and coming back here. Correct. Now let me assume that this distance is x. If this distance is x, what is the time taken by the boat to go downstream? It is nothing but x divided by, downstream means sum of speeds, right? 25 plus 5. Now it is coming back upstream. From here it is coming upstream. So say what is the time taken to come upstream? The distance x divided by 25 minus 5, because here you are subtracting the speed between the water current and the boat. Now this total time is given as 15, or I can say so x by 30 plus x by 20, that is equal to 15. So when you solve for this, what do you get the value of x as? What is the question? They're just asking you the distance of the place. Oh, don't take it as x. I took this as x, no? So take it as d here. Take it as d. See, x is 25 kilometers per hour. Y is 5 kilometers per hour. I've already used the variable x, so take this as d so that there is no confusion. Distance is d. So d by 25 plus 5 plus d by 25 minus 5 is equal to 15. Or when you solve, what do you get the answer? Yeah, d is equal to 180 kilometers. That is option A. So next one. Next we are moving on to races. See, races and all very rarely you see, but I thought I'll take 1 or 2 questions on this as well so that we cover that also. You get an idea of that as well. Yes, generally questions in time and distance, very common ones are the ones on relative speed or average speed or normal concept of time, speed and distance. Again, boats and streams, trains. Circular track and races very rarely you see, but yes, definitely you should know, because you cannot, we cannot say that this will definitely not come. You never know what can come in the examination, so it's better to be prepared. So here what is given? In a 500-meter race, A reaches the final point in 28 seconds and B reaches in 35 seconds. By how much distance does A beat B? What's the answer for this one? Give me the answer. See, again, question on races, you just need to know the basic formula. Distance is equal to speed into time. That is the only formula that you will be making use. The rest of whatever is given in the question is all logic that you should understand. Okay. Now, here what is happening? See, A 500-meter race. Okay, 500 meters is there. Now, A is reaching a point. A is reaching, okay. This is the beginning of the race. A is reaching the end in 28 seconds. Now, B is reaching end only in 35 seconds. So, when A reaches here, right, in 28 seconds, what will be the distance that is travelled by B? It is given that B is finishing the race in 35 seconds. So, B is covering 500 meters in 35 seconds. Or what is the speed of B? 500 divided by 35. Okay. Now, in 28 seconds, when A is completing the race, what will be the distance that is travelled by B? Speed of B divided by into the time, right? Distance travelled by B in this 28 seconds is nothing but speed of B into the time, that is 28. So what can I say? When A is completing this 500 meters, B has covered 400 meters. So by what distance has A beat B? A has beat B by 100 meters, right? This you get it as 400 meters. So this is the logic that is involved here. You just have to understand what is given. Solving it becomes easier. Correct answer here for this question will be option D. I hope it is clear. See, 500-meter race, B is completing it in 35 seconds. So speed of B is 500 by 35. See, at this point itself, don't waste your time solving it, finding what is the speed of B. Keep it as such there. Now, we know that A is completing the race in 28 seconds. So in 28 seconds, what is the distance that is travelled by B? B would have travelled 500 by 35. That is the speed of B into time, that is 28 or 400 meters. So when A is finishing the race, A is beating B by 100 meters. That is option D. Let's look at the next one. Next question. So try this one. Here what is given? In a 200 meters race, A can beat B by 31 meters and C by 18 meters. In a race of 350 meters, C will beat B by dash. Now again, one point that I would like to tell you when it comes to races is, see, sometimes in some questions they will give a sentence like this, right? A gives B a start of 6 meters. Now what does this mean? See, this means that, okay, when A is at the starting point, B is ahead of A by 6 meters, right? That is what it means. In some questions they would give some wordings like this. I just want you to understand what it means. If it is given that A gives B a start of 6 meters, that means that when A is at the starting point, B is ahead of A by 6 meters. Similarly, if I say that A beats B by 6 meters, that means that when A is in the finishing point, B is 6 meters behind A. That is what it means. So these small things keep in mind. What each of these statement, that is this line, what does it mean? You should know that. What is given here in this question? In a race of 200 meters, A can beat B by 31 meters. So when A is covering 200 meters, how much has B covered? B has covered 200 minus 31 or 169 meters only. Correct? When A covers 200 meters, B has covered 169 meters. And when A covers 200 meters, it is also given that A is beating C by 18 meters. So when A is covering 200 meters, C has covered 200 minus 18, or that is equal to 182 meters. Now let us look at this scenario. Okay, there is a race that has happened. So A has covered this 200 meters, C has covered 182, okay, and B has covered only 169. Now the question is, when if it is a 350 meters race, C will beat B by how many meters? So you have to find that out. See, when C is covering 182 meters, B is covering 169 meters. So if it is a 350 meters race, C will beat B by means when C is finishing the race, right? If it is a 350 meters race and C is finishing the race, where will B be? That's what they are asking. Where will B be and what is this distance between C and B? So when C has covered 182 meters, B has covered 169 meters. When C has covered 350 meters, how many meters B would have covered? B would have covered 350 into 169 divided by 182. Or you simplify this, you get this as 325 meters. So I can say that when C covers 350, B covers 325. So by how many meters has C beaten B? So C has beaten B by 350 minus 325, or by 25 meters. Correct answer here will be option D. Okay, I hope it is clear. See, in a 200 meters race, A can beat B by 31 meters and C by 18 meters. So I get that when C has covered 182 meters, B has covered 169 meters. So if it is a 350 meters race and C is beating B, in that case, when C is covering 350 meters, how much distance would have B covered? B would have covered 325 meters. So by what distance is C beating B? 350 minus 325, or 25 meters. Correct answer here is option D. Is it clear? So I think with that, we are coming to an end of the questions chosen for today's session. So, so what did we do today? We discussed the topic time, speed and distance. As I said, there are a very few concepts that you need to know when it comes to time, speed and distance, like the average speed concept, relative speed concept, and the basic time, speed and distance concept. That is the relationship between these three variables and the units of these variables. So if you know this, you can solve any question that comes from this topic. Then you will need to know like now coming to relative speed, application of relative speed is very, very important from this topic. You can have questions on trains and boats and streams. So again, you should know whether to add the speeds or subtract the speeds. So see, imagine the situation and then take a call. Generally, when it comes to boats and streams, see, one object is going on top of the other objects. So that's why if it is downstream, you add the speeds, right? Because the speed of one object will help in the movement of the other object. So similarly, if it is going against the water current, means you subtract, because the boat has to go against the flow of the water to move up. Yes, similarly, if you see the problem on escalator that we did, the same concept is what we used there also. So always think and decide how to take the relative speed, whether to take it as sum or difference. Do it according to the problem. Generally, if you have two cars which are racing or two trains moving opposite to each other, when the bodies are moving in the opposite direction, you add their speeds, and when they are moving in the same direction, you subtract the speeds, right? So all these you will have to decide depending on the question. Now, then the last small topics that we discussed was races and circular track. So I hope that was also clear to you. So in circular races, there is nothing that you need to know extra to solve the question. It is very basic formula. Distance is equal to speed into time that you will be making use. But again, how to approach the problem is a little different. So do try out time, speed and distance at home. Try out all the questions, additional and the advanced examples that is there in your workbook. And if you have any doubts in any of the questions, please do let me know. If you have any doubts in races or boats and streams or whichever topic from time, speed and distance, please do let me know. I'll definitely help you out in the forum. Yes, and please post your questions under quantitative ability subject or reasoning ability subject. Please do not post it under the titanium exclusive course, because many times I don't look into that. I always look into the queries that are posted in the respective subjects. So please post it in the subjects and I'll get back to you. Yes. Okay guys, so that is it from us for now, and I'll see you in the next session. And this is Gayatri signing off. Till then, take care. Good night.